Thank you.
Okay, so as Dr. Lighton has said, my name is Chisomo Singogo, Masters of Computer Science. My research is automated detection of road surface defects for enhanced road safety in Zambia. Yeah, so I'll start by talking about the challenge. I think I'll just read this slide verbatim. So Zambia is facing a critical road safety crisis. Despite the severity of the issue, current road defect monitoring relies heavily on manual surveys that are slow, laborious, subjective, and time consuming. While machine learning models have shown promise in detecting road defects globally, Zambia still lags behind. This highlights a significant gap and a pressing opportunity for developing machine learning solutions tailored to Zambia's roads. So, continuing with some of the issues, the problems, and I guess we could call it the motivation for this. So, currently, the accident rate on the roads is quite high in Zambia. So, some of the statistics are uh, 35,000 plus incidents and 2,100 plus fatalities in 2024 alone. Then obviously this results in economic losses. So latest reports are showing 16.7 billion, which is 4.7% of GDP. Then other issues are, as Dr. Lighton highlighted, we have had some informal discussions. So we had an informal discussion with the RDA. One of the things I highlighted was also data, lack of a place to store data and information related to some of these issues. So before I dive into what I'm doing exactly, I think it's only right that I acknowledge what others have done, because my research builds on top of research that was done last year. So these pictures are actually taken from the research that was done last year by, you can see at the bottom there, Daka, Peter et al. Yeah, so their research was portal detection and classification system for Zambian roads, a case study of Lusaka. So their research was focusing on building a machine learning system that will automatically detect potholes. So my research builds on top of this. The plan is to make one that detects a wider variety of road defects, of which there's quite a number. So I'm not just looking at potholes, but it's going to be a wide array of defects. So research questions, I'll just read through this quickly. Number one, what are the current road defect detection practices? Associated challenges, existing quality assurance mechanisms, and the limitations and specific technological needs of Zambian road authorities. And secondly, how can machine learning models be effectively created to detect and classify key road surface defects and be integrated into a prototype application? And thirdly, how effective, usable, and useful is the developed automated defect detection system prototype in real-world Zambian conditions, particularly concerning its potential to improve objective assessment and quality control in road maintenance. So the aims and the objectives. So number one, to characterize the practices. So basically, how they doing it right now, what's currently on the ground, how are the authorities carrying out their defect detection. Then secondly, that's going to inform how the prototype will be developed, and also it will also help inform what defects should be the model should be trained to look at. And then thirdly, we have to evaluate the performance of the system and also, yeah, how users feel about the solution that is built. So what's the significance of studying what the research that I'm doing? So firstly, obviously, it will enhance road management. So we know human beings are prone to mistakes. Human beings, yeah, someone might be tired that day. They may miss a few things. Yeah. And then obviously the goal is to improve road safety with this system. So if we can detect these defects, especially early on, uh, usually a lot of these defects don't just become potholes. They usually start off as cracks or depressions. So if some of these issues can be spotted early, it would mean, yeah, I think they say prevention is better than cure. So something within those lines, before things become worse, you can rectify issues, which will save money in the long run because you've sort of nipped issues before they get bigger. Then thirdly, I'm sure most of us have read through the national AI strategy. So, one of the pillars is the government, is sort of pushing and encouraging collaboration between local entities and the government. And I think this type of research is a perfect example of such a thing. Then the conceptual framework, I think all of us here in the Data Lab should be familiar with this. So this is the framework I'll be using. I won't dwell too much on this because I think we know this. Then my approach, I'll be using an exploratory sequential mixed methods design to carry out this research. So pilot study. So this is building, the plan is to build a small proof of concept machine learning model. So this one will just detect one thing. I've picked on cracks. So it's just sort of a proof of concept to show that this can actually be done. Then I'll move on to the phase of investigating the current practices. So this will involve interviews. We'll also want to get the public's perception of like how they feel about the roads and how things are. Then there'll be development of the system, and then finally evaluation of the system. So the model, the pre-trained model, I think is what they call it, that will be used is YOLO. Why YOLO? It's one of the questions I've gotten from Dr. Lighton before. So these are just some of the reasons. So obviously there's alternatives like RCNN, but RCNN is slower. So YOLO is quite fast because it utilizes single shot detector, unlike RCNN, which does it in 2 stages. So YOLO is faster. Then YOLO is not as accurate as RCNN, but it's not bad. But also the other advantages are it's easier to deploy. It's very easy to deploy. Then also there's good community support. So lots of documentation, lots of resources should you run into things like bugs and all that stuff. Then it's also highly customizable. Yeah. So here's just a quick flow diagram of my methodology. So first of all, it's the ethical clearance from UNZA. Then the public perception. So this is the stage where we plan to use Google Forms, send them out, and gather information about how the public currently perceives the current situation with our roads. Then we have interviews with the industry experts that will inform how we build the solution. And then there'll be testing and evaluation of that solution. And then all things being equal, there'll be deployment. So yeah, so I think these technologies that I'm currently thinking about using. So the back will be Python. I think it's almost a given at this point. The front will be in React, then the model, be YOLO. Then yeah, I'm thinking about using things like RoboFlow for images. So I think the advantage, or the thing is, I think road defects are universal. So a portal in Zambia is still a portal in Kenya. It's quite the same. So I think using other data sets would work in my case. And a bit of a high level view of the system. I know there's quite a bit going on here. But so you have the front end application. So the frames are sent to the backend server. The server then pushes it into the model. The model does its analysis and returns information back into the backend. So some of it will be stored in the backend, but the backend also sends a response to the front end. So the idea is the video, so it'll be video that's captured using a dashboard cam. So the videos will have coordinates on the bottom left. So whenever a defect is detected, the location is also captured. So those locations will be used to help used to help find the location on Google Maps. Yeah, I think I have some pictures coming up. Yeah, so currently for the prototype, the UI is quite simple. It's just so that the demo, the prototype. So this is what the front end looks like. This was not built with React, but currently what happens is you have a browse files button in the top right there. So that goes into the computer and you can select a video. Then it begins analyzing the video to detect the cracks. Yeah, so this is after it analyzes. Hello?
Yeah, I think Chisomo has a bit of an issue with his connection. Chisomo, are you still there?
Yes, you can hear me?
Oh, we couldn't, but you can proceed now. We can hear you. Thanks.
Oh, okay. I don't know what last you heard, but yeah. So I was showing screenshots from the system, the prototype that I have. So yeah, you feed the video, it begins to detect. It shows after the video is done, it will show you the locations. This was a short video, so it only has 3, just for demo purposes. Then after that, if you hover over a location, you'll be able to open it in Google Maps. And then, yeah, you can then click and then it will take you to that location. So For system evaluation, yeah, we use this system usability scale to get the overall user satisfaction of the system. And for the machine learning model, we use IOU precision, recall, F1 score, mean average precision as well. Yeah, and then just to conclude, yeah, these are some of the next steps of ethical considerations. My current timeline, subject to change, is I'm hoping March 2026. That's currently what I'm thinking. And then the final deliverables will be a prototype system evaluation reports, a comprehensive final research report. Yeah, and that's it from me.